Hello everyone. Today we're looking at similar triangles. This builds off the material from last week as well as some parts from similar triangles and congruent triangles from last semester. So, start things off. There are three ways to show that triangles are similar. We have the angle-angle similarity. That happens when two angles of one triangle are congruent to two angles of another triangle. We have the side-side-side similarity, when the measures of the corresponding side lengths of two triangles are proportional. So proportional side lengths. And then finally we have side-angle side. When we have two side lengths of one triangle are proportional to the measures of two corresponding side lengths, and the included angles are congruent to each other. So kind of similar to our previous forms of congruency between triangles, we're now looking at those in terms of proportionality. Let's take a look at some example problems. Example 1. Determine whether the triangles are similar. We have triangle ABC and we have triangle DEF. So first things first, let's check the sides. And if they're similar, we'd expect to see the longest side, middle side, smallest side. We'd expect them to all have the same proportionality based on our side similarity. So let's check our sides. We have the ratio of AC to DF, which is the ratio of 6 to 9, breaks down into 2/3. We have the ratio of, let's change colors on that, BC to EF, which is a 8 to 12, which breaks down into 2/3. And then lastly, we have a AB to DE, which is a 10 to 15, which simplifies down into 2/3. So we've got our 2/3 showing up on each of them, meaning that all the sides are proportional. And so this is going to be proportional by the side similarity statement. Proportionality statement in this case would be that triangle ABC is similar to triangle DEF. Example 2. Determine whether the triangles are similar. So we've got a side, and included angle, side, included angle. So if this is going to be similar, it's going to be similar based on our side, angle, side similarity. So first things first, check our angles. Angles are congruent. So angle N is congruent to angle R. Then we want to see, well, what's the relationship between MN and QR. Well, MN is 3, QR is 4, that's fully simplified. Then NP to RS, that's equal to 6 over 8, which simplifies down to 3 over 4. So our two sides are proportional and their included angle, which means that by the side, angle, side similarity, these are going to be similar triangles. And our similarity statement would be triangle NMP is similar to triangle RQS. All right, two more problems. Similar triangles can be used to find measurements. Example 3. Triangle ABC is similar to DF. Find the values of x and y. All right, so we've got our x, we got our y. So based on our similarity, we can find a proportionality statements. So for instance, we want to find our x here, we want to find our y there. Well, we have a known set of numbers of 18 and 9. So we can set up our proportionality statement, our scale factor essentially, 18 to 9, which breaks down to 2 over 1. We can therefore use that 2 over 1 to do our equations. So for x, our 18 root 3 and x, well, 18 root 3 to x must have the same ratio as 2 to 1. Do our cross multiplication or cross product. 18 root 3 equals 2x. Divide both sides by 2. 9 root 3 is equal to x. To find our y, or we're going to use y and 18. So y to 18 must be equal to our 2 to 1 ratio. Do our cross multiplication. Y is equal to 2 times 18, or y is equal to 36, thereby finding our x and our y. Word problem. Example 4. A person 6 feet tall casts a 1.5 foot long shadow at the same time that a flagpole casts a 7 foot long shadow. How tall is the flagpole? So if we think about the sun, let's draw a little sun up here for us. Think about the sun. The sun sends out rays of light that form two similar triangles because the sun's angle is going to be the same. Now these two triangles here would be similar under our side angle side relationship. So we can set up our equation. Let's set our unknown value as x. So we can say that 6 to x must be equal to 1.5 to 7. Do our cross multiplication, and we end up with 42 is equal to 1.5x. Divide both sides by 1.5. We have 28 is equal to x. So how tall is the flagpole? 28 feet. And that, folks, is the entirety of our similar triangles notes. Please complete the practice in the folder. We'll have an assignment on this for tomorrow.